So welcome to the Flow BI webinar, or kickoff to the webinar series, actually, with today's session. And today we want to talk about the fundamental problem in big data. That's essentially drove me years ago to start a project called Flow BI, which we later called Flow BI, actually. So yeah, and everything I show you today is essentially future technology, right? So there's no guarantee that anything could be released in the final release, essentially. So what's Flow BI? For those of you who don't know yet, essentially, yeah, I mean, to be short, Flow BI is a generative AI to generate the raw data vault. That's what it does. So it includes, it generates you the hubs, including the selection of the business keys, the links, the satellites, including security, privacy, rate of change splits. I mean, the satellite splits we typically apply, but also including special entity types like FAQ satellites, non-historized links, non-user satellites, reference data like reference hubs and satellites, and so on. There's quite a few entities that we support, essentially. And one second, sorry. And yeah, it's fully data-driven, which means that some of you know me from my teaching experience, and I used to teach for years what we call the data-driven approach to the data vault, and that's what Flow BI does essentially. It's a fully data-driven design, data-driven approach to the raw data vault. It integrates with existing data automation tools. So it's not generating you the final code. It's not generating you create table statements and insert into statements. It's actually providing you the metadata that you would otherwise type in manually into the tool of your choice. For example, let's say Data Vault Builder or the Scalefreeze Data Vault for dbt extension or Iris data, for example. So there's essentially, it generates you the metadata, essentially. That's it. Well, the metadata for the tables or the entities in more generic terms, for the entities, which will later be translated into the create table statements, but also the moving patterns, the load patterns. From where to where is a hub loaded? Well, we know the target, but from where is the business key coming, right? Or if you have multiple sources, or from where are your descriptive attributes coming for your satellites? So these load definitions are also part of the metadata that Flow BI generates. So, and we have the first generations already, where the tools they essentially absorb the metadata or load the metadata from Flow BI into their own offering, and then you're done with the raw data essentially. All right, that's Flow BI essentially in a nutshell. Who's me? As I said, some of you might know me already from trainings. Initially, so how did I get into the big data scene essentially? Initially, I was a software developer, and I was working in a small software shop where we developed a software package for the agricultural industry. It was essentially about feed formulation. If you feed cows, you need to know what you feed. They don't eat just grass, okay? And it was a combination of mathematical models and data, and I loved the job. I mean, I loved the topic, I loved the ideas. And then I decided that I wanted to essentially learn more about software engineering. That's when I started my studies in Bing. At nowadays the technical university in Bing, and that's where I really focused on software engineering. And then I had an exchange term with the University of Oklahoma, and that's where I was first exposed to data warehousing in a class essentially where the professor was teaching SQL Server and then with some ETL tool and just some basics. I mean, how to process data essentially roughly. And he became aware that I was actually working in a professional field before, and I was developing in SQL Server and other databases like Postgres and so on. And then he essentially gave me the first some share of the training essentially, so I could because he realized I was better in SQL Server than him. So I was essentially starting teaching the SQL Server stuff, and then I essentially got a scholarship for my graduate studies in at Santa Clara University in Silicon Valley. And that's where I was fully exposed to data analytics. I didn't do anything else. At Oklahoma, I had one class out of 4 in this term. And here I was taking most of, at least half, maybe more, of the classes were around data analytics somehow, expert systems, data mining, and so on. And and the other half was business classes. And so that was my essentially exposure. And then after my studies, I had my first startup. And I was essentially building a traditional data warehouse for some friends in the end who had some interesting business running. And I mean, not every startup succeeds, right? This one failed. And yeah, but this was my first exposure. And then I was working as a consultant essentially, and also with more traditional approaches until I stumbled over Dan Lindstedt, the inventor of Data Vault. And then I essentially wrote the book, Building a Scalable Data Warehouse with Data Vault 2.0 with him, co-authored with him essentially. And then I was essentially in the scene. And during my time in this data vault field, once I hit this field, I mean, this was in 2011, I believe, or 2012. The book came out 2015. People thought about, can you somehow generate part of the raw data vault using AI? Can you identify maybe business keys? Can you come up with hubs, links, satellites, right? Because people knew at Santa Clara I was doing a lot of data mining. My research was full data mining, right? So we did classification of unstructured data. Guess what? It helped later. So people talked to me about this, and I liked the idea, but I didn't take much time, or I didn't care about that back in the days, because I didn't have time. I was learning data vault essentially up and down all the aspects. That was my idea. Now, and many people have a similar journey into the big data field, right? I mean, here in the audience, I believe there's many people who studied something similar, maybe mathematical models, math or physics, maybe from healthcare field and so on. But they love to work with data, and that's how they essentially ended up here in this webinar. Now, what's the problem here? And because it all looks bright, right? It all looks cool. But what's the problem? And the thing is, I was about to say cool thing, but the thing is this: the problem scales. So we can really talk about the problems in your team, inside your team. What are the issues essentially in your project, and then scale it up. That's the basic idea. And the thing is, when you look at your fundamental problems inside your team, it's all about budget constraints. You don't have the budget you need essentially to come up with the to get all the resources you need essentially. You might have people problems. You don't have the right people. You don't have enough people, right? You might have the wrong people sometimes, and they might lack the skills that you need, right? So it's also an issue. Then you have maybe not the right technologies or outdated technologies, and there might be political reasons that you have to overcome somehow. And those are only a few problems that came up to my mind essentially when creating these slides. Now, we have some solutions. The problem is these are incremental solutions, and these incremental solutions don't scale. Think about this. You could increase efficiency to some extent, right? So maybe increase it by some percentage, but what if the fundamental problem, it scales faster, right? And it scales faster. You could improve your hiring processes to get better people, more people, the right people. You could do offshoring, nearshoring to some extent, but there's also a limit on how many people you have available. You could hire external consultants, but then again, the market for consultants is also limited, at least with the right skills. We had a Call of Duty many projects where work that nobody wanted to do, we had to do, right? So we essentially move people back and forth and guaranteed them that they can come back to the fun part of the project. You could improve the skills of a project of your team by training, for example, right? Or maybe job switching and so on, so people build more skills. You could increase your technology levels by having more automation tools, for example. And you could essentially deal with political issues. Terms are burned, or projects are burned, whatever, or maybe competing interests in your organization by campaigning for your project. So there are some solutions, but all of them are incremental. They only scale to some extent, but the problem scales faster, or increases faster, essentially. Now, we have many similar careers to mine. So I've met a lot of clients, a lot of consultants, essentially with a similar career path than mine, with maybe, but also career changes, right? It's also great because we work in industry as data specialists or data analytics specialists, data scientists, whatever you want to call yourself, where it's even great if you switch your career and bring maybe some knowledge from the client industry with you, which is also great. And I also met many students because I'm active at universities. I like teaching a lot, right? And I've been exposed to many students, and you see them at the beginning of the career, and you know, well, they will end up in one of these projects with all these fundamental problems, essentially. So the future is bright. We get more and more students coming out, right? So it should be bright, right? But not if you don't change this fundamental issue, essentially. Now, the problem is this. the issue is, and we have a blog article on this topic as well, where this picture is coming from, essentially. The problem is this: what I learned in school back then in 2000, whatever, 9 or whatever, 2009, 2010, we all learned back then that the data volume, but also the data shape, by the way, the data volume is increasing exponentially. That's what everybody learned for 10, 15 years now, or 20 years. And we've seen this all the time, right? So this chart here essentially starts in the year when I really realized this from my perspective, essentially, right? When I learned this, essentially, that the data volume is increasing exponentially. But the same is true for data shape. We have to deal with more and more data shapes all the time. That's the other issue, essentially. But the problem is, when we look at the current solutions require more and more people then, right? You need to have more and more people, maybe some automation, but it's not a automation doesn't brings you to at least what we know in industry at the moment doesn't brings you to the point that it will scale drastically, because you still have to analyze the source systems, you still have to analyze the data structures and so on. Volume is an issue, but not. I mean, in my opinion, structure is the bigger issue from a man point or work point perspective. So, and the problem is, it's not that the number of students who get done with their studies exponentially increases. They come from universities, they come from apprenticeships like me back then in the old days. And there's only a limited number of universities with a limited number of seats. They will not increase exponentially, right? So that's what it is. The number of new students or graduates actually is slightly increasing, yes, because it's a more and more popular field, what we're working here, but it's not increasing exponentially, it's increasing linearly, right? And the other problem is there's also retirees. People want to get done with a job one day and relax and enjoy their retirement. So it will never be an exponential curve. That's what it is. When we think about big data, we always have these 3 V's essentially in mind: data volume, data variety, and data velocity. You know them already, so just briefly, right? Data volume is measured in bytes and records. Data variety, we talk about structured data, semi-structured data, unstructured data, and then data velocity is batch and streaming. I want to focus today on the volume and the variety, because that's for us here, at least for today, more interesting. Data volume, that's increasing exponentially, as I just said. And it's often the focus of any big data discussion, because volume is what people can essentially, it's very, I would say, handy. It's easy to understand, essentially, right? Volume is something like liters or gallons in water. So that's easy to understand. So that's often the focus of any big data discussion. So when you search for big data, and it's all volume. And then the thing is, when the problem with volume, or the good thing with volume actually is, volume aligns with the exponential growth of computer power. So there's this Moore's law, right? And Moore says that the number of available computing resources to your individual team, or you individually, or to the industry, is increasing exponentially as well. So that's all good, because it means we can deal with the ever-increasing, exponentially increasing data volume. That's fine. And it also aligns with the exponential decline in storage costs. By McCallum, not that much known, but as was Moore's law, but still true. I mean, we observe it all the time, right? Storage becomes cheaper and cheaper. So data volume is not the big issue here, because we have exponential solutions, right? But what about data variety? And that's what people always talk about, and I just did this as well. They talk about structured data, unstructured data, semi-structured data. But what does it mean? The problem is that with more and more data available, they all come with their own structures, right? So you have more and more structures available. More and more data means here more and more structures as well. And that's also increasing exponentially. There's some research on this, actually not on how data variety increases, but on how software complexity increases. And I truly believe that the data variety aligns with that as well. So the more complex software gets, the more complex data structures you get, and that's why you get more and more complex data structures to be analyzed. That's my opinion. You might agree or not. There's no clear research on this, to be honest, or at least I couldn't find a good one. So that's the thing. And that's often forgotten. People think about unstructured data, binary files, or maybe JSON documents, but they don't realize even structured data, tons of structured data, right? Tons of data becomes semi-structured over time. And you have so many structures, you have to analyze them. And that is the problem here, because that requires manual work. you can't, at least until now, you could not essentially plug in some data sources and let some system do the work for you. You have to always analyze the data, integrate the data, and so on. And that's the issue. It's not the volume, it's really the data variety. And we have some solutions here. So there are some solutions out there in the market that help us to deal with these issues, especially this variety issue. For example, there's some automation tools for data warehousing. You guys might know Data Vault. Data Vault is essentially a concept where we can, which we use to integrate data on an enterprise level, but also in small SME cases. And that's a concept which is essentially designed for automation. So we can use it for automating the loading procedures, the model essentially, because everything is based on patterns. That's a cool thing. And there are many tools out there. And Flow BI partners today with Data Vault Builder, which is a tool that runs in the cloud. Essentially, people love it because they can essentially model their concepts, their data, map the data to it, and then generate the raw data vault from it, all the way down, actually, including Business Vault and including information marts. It's the whole solution, essentially. Then we have Data Vault for dbt, which is an open source package that essentially integrates with dbt, which is a popular framework for data movement, Python framework, essentially. And Data Vault for dbt gives you the patterns on how a hub link satellite looks like, how to load a hub link satellite, and so on, right? FActivity satellites, all the special entity types. And then we have Iris. Iris essentially sits on top of a automation engine and simplifies the design of the raw data vault and all the way essentially downstream, again for processing the data vault model essentially, or generating the data vault model essentially. And all of these tools have one in common. They're all based on metadata. So you have to set up the metadata, and then based on the metadata, they come with templates. And templates, they apply the templates to the metadata essentially, and then they generate you the code for the create table statements, for the insert statements, for hub sync satellites, and so on. That's the basic idea. So there's some tools out there, and there's many more actually. But those are where we partner with already, and where we work actively on integrations already. And while they have some similarities, they also have their own, let's say, specialties, I would say. So for example, Data Vault Builder, people love it because you can graphically model the data vault model essentially, right? So that's what people love when they use the tool, when they refer to the tool. They love the user interface. That's a big advantage. It's easy to use. That's, I would say, is where the vendor would agree with me easily. Then we have Iris, which is metadata driven. Again, every tool does this. Here, it's really easy to set up the metadata, which is nice, especially if you think about feeding that metadata from an external system into it, right? So that's cool. User interface, very simple user interface as well. And then we have Data Vault for dbt, which is an open source package. It's Python based, so you would configure the work mostly in YAML files. There are some graphic user interfaces as well, where you essentially can set up these YAML files as well for your model, and then it's easy to integrate with CI/CD pipelines and so on. So every tool has some advantages, their own capabilities essentially, and I would say there's no perfect tool out there. I mean, every vendor would disagree here, but there's no perfect tool, and you must make a choice which is the tool of your choice. And that's my personal opinion at Flow BI as well. So we want to partner with everybody, right? And that's your choice as a client. Now, the thing is this: if you are working a data project, here's a quote: Data Vault 2.0 without automation is like farming by hand, and you can quote me with that. I never put out so many quotes. This is my first quote actually, but I truly believe this. I mean, no farmer out there would farm a land without any machinery, right? Except if it's your hobby of yours and you want to farm a couple of hectares land manually. I mean, people might love it, but a professional farmer who wants to make money and feed a family with it would never do this by hand, essentially. They always have machinery, and same is true for a Data Vault project. In a Data Vault project, you want to automate. We only do a Data Vault project with automation at the very beginning to teach the team how to design hub sync satellites, how to load hub sync satellites, and how to leverage them. But then once they understood that, they want to really automate. That's their goal, essentially. And that's what we do. So every Data Vault project I was working in the last years was using a automation tool, one or the other, to the choice of the team, but they used a tool essentially. All right. So yeah, is more automation the solution then? Because that sounds essentially, I mean, automation tools are in the end still incremental solutions because they help us to speed up the generation of the code. But still, you have to still set up the metadata for these automation tools. That's the problem. Still, all these tools are based on metadata. All the tools I just presented are based on metadata, and you have to set up the metadata for these tools essentially. That's the issue. So what are the current pain points in a team or in a project? First of all, it's the availability of qualified data modelers. So you have these tools, but you need somebody who sets up the metadata, and they must have data knowledge. You can get them trained, but in the end, you need those people, and the more experienced they are, the better. So there's a limitation of consultants, limitation of employees, team members that are available on the market in your organization that you can train. That's what it is. And you have to do source data analysis. You have to look at the source data sets, talk to the business, and then analyze what's going on here. Does the data relate from one system to the next? What are the relationships inside the data source, but also across data sources? How to split or classify in the first place, classify the attributes in the security and privacy and rate of change classes, and then generate the code essentially. And and then you have to set up the metadata in the right way. So even if you understand the source data, even if you know Data Vault, you need to know the target tool as well, where you set up the metadata. And the metadata must be correct. If you feed bad metadata or bad templates into this space or into the solution, then your code will be as bad as your metadata or the template essentially, right? So you need to understand how to set the metadata for the respective tool. You must have the tool knowledge to set the metadata essentially. Those are the pain points, I would say, if I'm focusing on the raw data vault alone, right? The more downstream you get, the more you have to talk to business people to understand how to apply business logic to the data, how to derive the target model, and so on, right? How to present the information and so on. But that's all. Those are, I would say, the pain points for the raw data vault, for the first layers, the data-driven layers, right? That's the focus of Flowia essentially. So what kind of solution do we propose? What's the future solution here? First of all, what I learned at Santa Clara, it's as I said, I took a lot of data analytics classes, but also a lot of business classes. And one was about innovation. And there's two types of innovation. One is what we saw already, the incremental innovation, right? Where you essentially introduce some incremental solutions for your problems. They will improve your situation to a bit, but the fundamental problem is much bigger than our incremental solutions. So we need some disruptive solution to solve the problem, or to at least have a solution that scales with the problem. And that requires to change the way we think, how we work, how we act. That's number one. So we have to have a bit different thinking. And to that extent, the data vault is a disruptive concept. When I started learning data vault, I loved the idea because I realized it's disruptive, and that's what I want to go for. I'm going for these disruptive ideas. But the problem with data vault was, back then in the early days, it was an uphill battle. There were too many people, too many parties in the industry who had success with the current solutions and with the current way of thinking, and they were profiting from it, right? So why should they change to something completely new, unknown to them, and also with some high risk, right? So why would they go there? Well, maybe because that's your future. Maybe if you realize that there's a disruptive technology that might require some way of thinking, different way of thinking, but has the potential of essentially solving your problems and scaling with your problems, that's the future, because these incremental solutions will only work to some extent. Now, think about this, photography. When we had these analog photographs, a lot of people had these little shops where you could essentially bring your film, and they would develop the pictures, the photos for you, and get some payment, essentially. Fine. Well, guess who was, and they were photographers and so on, right? They were used to analog photography and so on. And then came these ugly digital photographs, right? We had these low resolutions, images of, I remember the first one's VGA resolution. It was a big deal. What was it? 480 to 640 pixels. That was the image essentially, right? And so everybody said, what is this for, right? What do we need this for? Well, the photographers didn't use them because it was didn't give them the exposure of the light. They didn't have the limited number of pixels. You had these, the local shops. There was no need to develop these pictures anymore because people had their computers at home and they were just uploading them on their hard disk, right? At least most of them. So back then you had to develop all the photos first and then realize which photos were good, essentially. So there was a lot of essentially for these digital photographs. There was a big uphill battle, essentially. But think about this, it improved over time because the pixels was just a start, right? Nowadays, I'm not sure what today's technology says, but it's in megapixels, essentially, where nobody cares anymore. That's not a big deal anymore, right? It's integrated in your mobile phone. I mean, it killed to some extent the market for the, what's it called? I don't even know the name anymore, for the photographing engines. So again, another party who was against it, right? Now it's all integrated in your phone, and it's just convenient, and that rocked the market essentially, right? And that's the deal with disruption. So it's always an uphill battle, but the cool thing is this: I went through it already with Data Vault. That was the same uphill battle as well. A lot of people were essentially were involved in the current processes and projects and thinking, and then came Data Vault and took the market. I'm not saying it's done. It's still uphill. The uphill battle is not there anymore because people see the value of Data Vault, and the adoption increases very nicely, essentially. And yeah, so it's not the early uphill battle anymore. It's not flat anymore, but still, yeah. All right. So what's the solution then? And in my opinion, it's AI, right? Question mark. I'm not sure. So let's talk about this. The thing is this. You could argue we need more data scientists to solve the problem, right? Because more volume, more shapes especially, requires more data analytics, data analysis, more data scientists to analyze the data sets actually and integrate them, come up with business logic and so on. But the problem is, well, that deals with the problem of the manual metadata definition, right? That's a fundamental problem. And to solve this now, if you say, well, we need more data scientists, that means we need more babies. Right? And they must become data scientists. So they should not become pilots or nurses or something. No, all of them must become data scientists because we have an exponential problem here, right? So, and we have to scale the university output. Well, this will not scale. It will not work, right? That's not the solution here. It can't be the solution for our problem. And that's why we propose AI as an alternative solution. AI scales because it's limited by the compute power and storage power, and those we just discussed, they scale, right? They scale exponentially. So with that in mind, AI scales as well in the same manner. And we can actually even come to the point that we process data faster than it's being generated. That's the other cool thing. So we can, while at the moment our teams, they have to analyze old data, previous data from, days ago, years ago, sometimes. And with AI, you can get much, much closer to the point where the data gets generated, to the point in time, right? So that's another big advantage. And it increases human productivity because think about this, on this globe, there's a number of people and only a subset, a small fraction are data scientists. We all think here in the room or in this webinar that our biggest problem is data, right? That's our thinking, our niche here. That's what it is. But that's the problem we have to solve, right? Other problems will be solved by other people. We have to solve data issues, and with that, other people can solve their problems because they have to have information, trustworthy information, to work and solve their problems. So that's what we do here, right? So it's fine that we focus on our problems that we can solve. And if you think about the globe, we're limited, at least regarding data, of this small fraction of people on the globe who process data, who are able to process data. That's our limitation. Now, if we can scale up, if we can process more and more data, I don't want to overstretch it here, but human mankind will profit from it, right? Because more and more data is being processed, more and more information, reliable information becomes available, and so other people can do their job, feeding the poor, making more cars, whatever it is, right? So that's what it is. They need information for that. So as I said, FlowBI is an AI that generates the data vault. It's really focusing on the raw data vault. That's the I would say the focus of the engine. of this solution, of this concept. Well, it generates the metadata for the raw data vault, but with that you can define every layer before that as well. Like the data, the staging area on your data lake or on your relational engine works as well. Flow BI has that metadata essentially available. And to achieve that, we essentially imitated the human data modeler. To be honest with you, I didn't build a full system by myself, right? We were a team of 7, 8 people in the early days, and but the rules how to set up the data vault came from me. So I don't want to overstate it here again, but it imitates me, to be honest. So that's what it is. So Flow BI develops a data vault as I would develop a data vault essentially, because I built the rules on how to set the layer up essentially. And a lot of people until May 8, when we published Flow BI for the very first time, thought that AI can only assist the data modeler, right? Maybe give you some suggestions, and you, as a data modeler, you make the final decision. But I said, what if you can turn this upside down? So I started thinking about Flow BI years ago, and my initial idea was really to give the AI the lead in the generation process, and we as humans, we influence the AI. That's the big difference here. I wanted that the AI takes the lead and generates the model, and we can influence the system to come up with a better model, whatever you define it. And what Flow BI does is it generates the logical design. The logical design of the raw data vault layer and the staging and data lake layer, as I said. And that means essentially it will not generate you the create table statement, but it will define what hubs, what links, what satellites exist in your raw data vault, how to load them based on your source data sets, that this business key is being loaded from these 3 source tables, right? These attributes are loaded from these satellite attributes are loaded from these source tables, and so on. And it will also define the business key to be used for all the hubs, for example. But also identify the reference tables, the non-historized data, it doesn't perform the satellite splits, but it will tell you for every attribute what privacy, security, and rate of change level this is for the attribute itself. And then the database automation tool where Flow BI integrates with, they will decide what it means. What does it mean there's a hub? Well, it means there should be a create table statement for a hub. How does it look like? It's all based on a template in the database automation tool. What does it mean if there's a classified attribute reading security, privacy, and rate of change? Might mean satellite split. Doesn't have to, by the way, but might mean a satellite split. So those are the decisions made in the physical model, and we don't generate that. We only generate a logical model, only because that's already a big deal if you ever modeled a data vault once in your lifetime. So the physical model is really performed by the database automation tool. So Flow BI hands over the metadata to, for example, Data Builder, Iris, or Data for DBT, and they will apply the templates inside their solutions to the metadata from Flow BI, and then essentially generate the target code. That's the big deal here. And then you're not out of the job here, right? So there's so much more work to be done, and you can really focus on the business value now. Because when you build a raw data vault once in your lifetime, you know that it's tedious work. You have to analyze the source data sets, identify the relationships, and so on. But there's some patterns behind this, I can surely say, and it's labor work, to be honest, right? And now you can really focus on the business value, and that's really implementing the business vault and the information marts. That's the value, where you essentially model information marts according to the needs of the information user, on their dashboarding needs, on their information needs, whatever they want to do with the information, right? Where you design dashboards for it, where you implement the business logic into the business vault, where you essentially, in that on top of all what Flow BI does. So who's assisting who, right? We assist in Flow BI in generating the raw data vault, and Flow BI assists us in generating the data platform. That's our goal, right? That's what we want to do. And Flow BI is essentially doing all the modeling decisions for the raw data vault, all the source analyzers for you, correctly setting up the metadata. The integration is done, so you don't have to think about how your automation tool of your choice, how to set the metadata, because that's all done by integrations where we work with the vendors together. Flow BI is not doing these integrations as well. It's done by the vendors, essentially. They integrate with Flow BI. We just give them the metadata in our form, and they transform it into their structure, essentially. And And then the data transformation tool creates a physical implementation for the staging area on your data lakes or relational, whatever, and for the raw data vault. That's what is done. And then on top of that, you build a business vault, you implement all the business logic, you implement all the information marks, you design a dashboard. That's the future, in my opinion. So it's assisted working, right? So is this just a vision? No, it's not. We've been working on this for quite some time, years, and we've built this, right? So Flow BI is a service that I'm using the next webinar to show you some at least parts of Flow BI essentially, and the solution is there. We're building the integrations already, right? So that's the current state. If you're interested in Flow BI, contact us, get in touch with us, right? We would refer you to a partner because that's how we work. I want to have Flow BI focusing really on the software development, on the AI improvement and so on. That's our goal. And the implementation is done by partners. What we do are trainings. So if you're interested in learning more about Data Vault as well to some extent, but Flow BI is the generated Data Vault. That's what you want to learn, essentially, the AI generated Data Vault. Then consider joining our trainings at flowbi.trainings, or send us an email, trainings@flowbi. That's where you can essentially set up your training. There's one upcoming shortly, so I don't want to name dates because this will be a recorded webinar, right? But yeah, check it out, and that would be nice if you join. That's where we teach about all the concepts, how to use Flow BI. You get live access to Flow BI actually, to the system. You can point and click and follow the training exercises essentially, and where we look at the metadata, how we query the metadata, how we use the metadata, where we essentially talk about how to improve the model, how to improve the results of Flow BI, how to influence the system essentially, right? And then how to use it downstream essentially. That's all done in the trainings. It's 4-day training. So yeah, check it out. All right. Any questions from your side that I can answer here today? We answer a lot of questions in the training. You can also send me just an email, right? Or yeah, send me an email on info@flowbi, for example, when you have any questions, or register for the newsletter if you want. Okay, I get a few questions coming in here. How to market Flow BI internally? How to convince managers that Flow BI is a tool to be used essentially? What I would say is this: again, Flow BI is disruptive, right? So you always step in on the foot of somebody. Somebody has built something or brought you the people and so on, and you step in on the foot of them. That's what you have to be aware of, first of all. I would say, first of all, give it a try, right? So that's number one. Test it. That's what I would say. What I would do is, just like when you introduce Flow BI, introduce Data Vault, I'm mixing up these terms here. I'm married with both terms. When you introduce Data Vault, you're also focusing on the pain points. So if there's no pain point, they have a lot of budget, all the right people and so on, all good. Flow BI wouldn't bring anything to the table, most probably. Might be more cheaper, that's one thing. But focus on the pain points. What's the pain point? And we talked about those, right? All these these issues, the fundamental problems, the missing people, the budget constraints, technology limitations, and so on, right? What are the pain points? And when you talk to managers, when you need to convince your higher ups, essentially, you always focus on the pain points. That's the idea, essentially. So that's what you want to do when thinking about this. And Flow BI can bring a solution to many of your pain points. It scales, so it doesn't matter how many tables you have to ingest. The more, the better, to be honest. The more data shape you have, the better. Flow BI is designed to deal with data shape, not really with data volume. Data volume, it doesn't care. Flow BI is based on MDP systems, so everything scales. But if you have only one, let's go to two extremes. So you see the problem, the advantage of Flow BI. Let's say you have only one table, core records, but lots of volume. Yeah, we can analyze this, but it will become expensive because Flow BI is data-driven, so it looks at your data, right? So it will analyze all these petabytes of data in only one structure. Just model this by yourself. You have a data volume issue, not a data shape issue. But then think about your 60 SAP installations, or maybe I know some projects, some organizations where they have 60 ERP systems from all the vendors, not from one vendor, from all the vendors, right? So they have thousands 10,000s of source tables to be analyzed, right? And they only get a few done because they have a limitation, right, of how many tables they can analyze per sprint with the number of people they have and so on. And that's where Flow BI excels, because Flow BI doesn't care how many tables you have to analyze. Everything is scalable. So if you have 10,000 of tables, we spin up 10,000 of nodes, and I'm not kidding, right? So that's what Flow BI does. It solves the problem by massive MVP power. That's the idea. And yeah, it will get cheaper, but you will have more data shapes, more volume in the future. So it will scale. That's the cool thing. That's a cool idea. So that's how I would convince managers: focus on the pain points that you have in your team, essentially. And the more shape you have, the better it is for us. The better our solution will become. Volume is not a big deal. I mean, we can deal with volume, but you have the biggest advantage when you have to deal with data shape, not data volume. That's the idea. Because that's a fundamental problem, actually. How to motivate a team to use Flow BI. Yeah, okay, so that's essentially a reference to the internal issues. And we had the same when introducing Data Vault, again, some disruptive technology or concept. People are against it because they learned all the other stuff. Don't want to say old stuff, the other stuff, right? So they all learned these other concepts, and they essentially struggle with learning something new. They like the previous way. They have been made a lot of success with the previous way, and now you come around and say, well, here's something new, right? That's the issue. So it's convincing and really doing a POC, testing it and looking at the results, not imagining how this could solve your problems or not. Just try it out. That's what I would do. Give it a shot, try it out, and then look at the results and compare with what you do at the moment. That's what I would say. All right. Any other questions? Okay, cool. So thanks for joining. Yeah, thanks for joining today. There will be another webinar on Friday in a couple of days. We talk about the next topic. One second. Is your business AI driven? We talk about how we can leverage a technology like Flow BI inside your, at the moment, data-driven organization, or the to become data-driven organization. And we say, well, why should we stop there? Why should we stop at a data-driven organization? Why don't we talk about AI-driven organizations? What can we do with this technology, essentially on the larger scale, essentially, right, on the higher scale? All right, cool. Thanks for joining, and see you on the next webinar.